At least you can say your surname is very difficult to pronounce.
My surname is Whittingslow.
Thank you.
Okay.
Patricio has 4 years of professional experience in the aerospace industry as a mechanical engineer. We did his software expertise. Working at Satellite was a good one.
Oh,
Yes, the Aerospace and Nova Space developing in-house software models for space mold systems such as solder joint fatigue failure simulation and rigid body 6. It is offering trajectory simulation so with models or for all propagation.
all right. Thank you, Noel, for the presentation. Thank you all for being here. Well, let's dive straight into it. What is Go? Maybe you're asking yourself, Go is a programming language. This presentation, I'll be going over why you'd want to use Go for aerospace applications, and also some examples on where it can be used. So this is one of the problems, far from being the only motivating problem, or most motivating problem. Usually when you work in a company, you have multiple technology stacks. For embedded systems, you have teams that might use C++, 26, C. You have different versions of C and C++, which are very different between themselves, in case you weren't aware. Python is also a contender, data analysis, Fortran for heritage models. And Les Johnson pointed out that when starting a new project, there's often a dilemma whether to reuse existing stacks, so maybe your Fortran sort of flight trajectory calculation, or whether to start a new project from scratch. And an example, Hubble at one point was about to be terminated, and the only reason Hubble was not discontinued was because they received letters from elementary students petition to keep it going. So sometimes it's not even in your team's control, it might be in their hands of first grade. All right, so Go, maybe some of you have heard it, a web language. I prefer to say it's a language in service of engineering. Go can be used for embedded systems, machine learning. It's being used at NASA JPL right now as a peripheral control language. And SpaceX is also reportedly using it. You can also use it to engineer organisms. And Docker and Kubernetes are written in Go, so 90% of infrastructure now is deployed onto programs written in Go. Go is a very batteries included language. Just these tables. They're not to look at in depth, but to just give you an idea. Go just brings you most of it for free. No arguing with your engineering team about which profile or what style to use for your code, right? There's plenty of highlights when talking about Go compared to Python, C, and C++. It's a language that had engineering principles in mind from the beginning. And there's also some stuff that Go doesn't have, right? Compared to Python, C++. Although Mark Maimonen, the principal in autonomous navigation on interplanetary software from NASA, he says that these features are missing from Go, are things you would want to not have or prohibit on your C++ software, which is running on Curiosity. So the Go community opposes the stuff that you do not want to have if you're writing software for NASA. Performance-wise, it's often said that Go is a language that suffers because it has a garbage collector, a runtime. When you compare it, writing equivalent data structures and algorithms, you find that Go really performs on par with C, C++, Rust. The blue line is Go, the standard compiler. You also have alternative compilers available. So the green line is TinyGo, which also compiles Go code. And you can see it's pretty much on par, at times better than C and Python doesn't, it's not meaningfully comparable at this level. This is another benchmark I'll be showing, written by my co-author, Juan Pablo. He couldn't be here today. So it's a lunar moon transfer from GTO to lunar orbit using a restricted three-body problem with a low thrust satellite, right? And simulating this with an integrator, you get about 200 times speed up when using Go. This is using SciPy, by the way. You can find more details in the paper. But you can go from iteration times, looking for a good orbit, from weeks to hours. So I find this pretty meaningful. And even when you can outsource most of the algorithm out to C, and instead of running in Python, you're still going to be slower, in this case, 4 times slower than Go. Here we're rendering an implicit geometry for 3D printing. Go is also used in embedded systems, more on where later, but the ways you can deploy Go to embedded systems are with TinyGo. It deploys to like 90 plus MCU architectures across 160 depth ports. You don't get this with MicroPython. And I mean, other than Arduino, I don't think there's another SDK out there that supports this many architectures. Below you have some papers, which I found TinyGo actually results in no runtime jitter when running on microcontrollers compared to C, Rust, and MicroPython. So if you're writing in real-time systems, Go might be for you. And performance, binary size, matches C. And I like to say get the best of both worlds. Simple, robust language with access to bare metal features. And here's a absolutely mind-blowing framework or project called TinyGo. You're actually able to deploy your Go programs to your computer with no operating system with TinyGo. So a Wi-Fi shell boot, you can do that in pure Go. No dependencies other than maybe a little bit of assembly. And if you, that's a 3 megabyte image for just a bare Wi-Fi image. And if you're adding SSH features to your Wi-Fi shell, you get a 9 megabyte image. Security and systems engineer, I find this to be maybe something you'd be interested in. You don't depend on external providers like Linux. You're completely owner of your stack. And there's also a Go team. It's a little project, a library that lets you do lockstep execution for like comparing results at the end of a calculation. And if it deferred, maybe due to a single event upset, and you can do that in 21 lines Go with Camila. So, and there's the embedded Go ecosystem is pretty big. There's plenty of other projects like embedded Go, Egos, and Go Crazy Go from there. GNCO. So now I'm going to show you some examples of where hopefully you've got an idea that Go, it's used, and now I'm going to show you where you could use it. Well, there's this GNCO is a library me and my co-author wrote for flight dynamics calculation. So it's got your typical orbital elements module, nozzles, coordinate frame transformation, atmosphere, aerodynamics. But what I find most compelling, and examples to get started, what is most compelling to me is the integrator we've implemented, which is a Runge-Coda Nystrom or Order 12 integrator with adaptive stepping. Let me show you why it's so interesting. So I've talked to some people here in the conference and they've said, oh no, Runge-Coda 4.5 is perfectly fine, right? Dormant prints integrator. And here we have this is one of the examples in the repository, which is open source. There's a 10 times difference in the energy error of a Keplerian orbit, so semi-elliptical, after 94 steps at 300 second step size. 10 times difference in the exponent, right? We're talking about 10 billion times more error when using Runge-Kutta 4.5, which is a little bit of more error than what you'd get with an ice-cream integrator. And it's just half as fast, right? So some food for thought, maybe maybe you want to be twice as fast. You get 10 billion times more error, something to consider. Also, let's talk about, don't take my word for it. Let's hear what an engineer at NASA JPL has to say. They are using Go. This is a spoken testimony. And the engineer has told me they're using Go at the Roman chronograph at the Nancy Grace Observatory, and they are using for the closed loop picometer wavefront control. So this something has to run with a 200 microsecond control loop. And what they found, and reasons why they're using Go and not Python or C++ are sort of detailed here. More like mainly Python is slow and it's hard to read and write Python because it's got some design decisions in the language which are not great. Mainly error handling. It's not great in Python. Well, more on the paper. He also mentions the reasons why he doesn't use C++. I mean, in the same amount of time, this person is saying that I can write a Go program that works, and it's probably faster than a C++ program I can write in the equivalent amount of time, besides all the concerns around memory safety, right? So, and lastly, I want to talk about the Fortran transpiler we have developed and are still developing. Some of you may be familiar with GeoDin, orbit determination software written by NASA. And we apply, so Fortran transpiler converts, in this case, Fortran code to Go code. In the process, we analyzed the code, and what we found when we applied the transpiler to this Fortran software has 500,000 lines of code. We found several bugs, some ranging in criticality, right? So you have missing arguments, which are not so serious in Fortran, but also cases of stack corruption. And the transpiler made it trivial to identify the place where the bug was and how to fix it. But we weren't able to actually run the GeoDin software. We're still working on getting there, because that's a lot of code that you have to verify. We did, however, get a flight trajectory software written by the Argentine Air Force called TRAEC to be completely transpiled, no human intervention, and we found 3 out-of-bound accesses, which resulted in garbage results in the simulation results. And the Go program actually, when after being transpiled, would crash. So whereas Fortran would just run to the end, just run and output garbage results without alerting you, Go instead crashes. So you also get these runtime error detections. And if you're interested, please contact us, read the paper. We'd be more than happy to help you out with your Fortran heritage software if you're using. So, Go obviously sounds really good up to this point, but it does have its limitations. No DO178C certified toolchain, so you're not going to use it in airline flight software. You do require some allocation of discipline because Go has a garbage collector. You can, however, use tooling to sort of limit the allocations. The scientific ecosystem is pretty small, but growing, as I've shown. And some low-level patterns still remain easier in C. So this is just a summary of what I talked about. Go really, I feel, brings the bar down to writing robust flight software, embedded software, and even ground chronograph software, as the NASA JPL person can testify. So that's all. Thank you for your time.
Thank you, Patricio, for the presentation. Any questions for Patricio?
Hello, thank you. Do you think it's a matter of time that it takes over everything, or that it is better for some things and the other programming systems are better for others?
I think there's still a lot of discussion online. There's, people who use Rust are going to say Rust is better, and people who use Zig is still on an up-and-coming language. It's still not in version 1.0, but I see those two as the main contenders, and I feel Rust is very niche. It's still a very a language that really carries its cognitive load when reading, and when working with big engineering teams, you can't expect everyone to have the same expertise in using the language, and Go really bridges the gap between the person who just wants to do data science and the person who's writing critical embedded software at NASA. That's why I think Go is a very good contender. I also mentioned Zig. It's time will tell, I think, whether it's Zig or Go, the de facto language that's used for just engineering, I'd say.
Any other question?
Some of the value you found in the NASA software and you pay
But I didn't hear it. I can repeat. So if I submitted the bugs I found.
One more, please. Wait a minute. Question.
Okay, what is it?
Yes, if I've submitted the bugs.
Yes.
I have not submitted the bugs because I'm not sure where to do it. But I'm sure there's plenty of NASA knowing people here who can direct me where to. That's Johnson is going like this, so I'm not. Yeah, I don't know where to submit them.
Thank you. Very presentative, by the way. Given the good proliferation of language so far, what is your experience with AI models writing Go?
Oh, I love AI models. I'm not going to say them all. I don't want to give free propaganda for the model I use, but yeah, I find that for Fortran, for writing this Fortran program, it has been completely invaluable for the development, because there's some stuff in Fortran that you would not believe how obscure and just twisted the language is, and having an AI model with an encyclopedia of knowledge is just so valuable. So yeah, and then there's the question, would I use an AI to transcribe Fortran to Go? Why not use an AI, right? That's a question I expect maybe some people have. I don't think you can transcribe 500,000 lines of code, deterministically with an AI yet. I think we're even pretty far away from that. So using AI to write the tool is, I think, good, but then don't actually write the software. I think it's just going to be more expensive than actually writing the tool.
Thank you.
And what's your question, and we'll pass it over to presentation because of the time now. Which do you think that will be the contributions with the highest impact, potential impact on the space industry of this shop in the next 5 years?
Well, I really hope the Fortran compiler is picked up by the companies which are still depending on Fortran code, so we can bring over all these disparate tools in the industry that have been used since the 50s, right? Fortran is a language that's been in the 50s. We've written a lot of code in that time, and we have. I've seen so many programs in Fortran, private, public. I think we can do an effort to bring those programs into like to the future by using a transpiler and really leverage what our ancestors, did, because there's a reason we're still using those programs, because they work fantastic. So yeah, I have my hopes on the Fortran transpiler and TinyGo for compiling to embedded systems and eventually having the first satellite programming in TinyGo.
Well, thank you, Patricio. Thank you very much, and congratulations for the presentation. Thank you.
Thank you very much.